Alright, so this lesson is called Absolute Maxima and Minima. We have already talked about relative maxes and mins, but today we're going to talk about the absolute extrema. Remember, extrema just means the max and the min both. So the absolute maxima is the overall max of all the relative maxes in an interval. In other words, just like the name implies, it's the absolute one. It's the highest one. So if you had a graph that kind of had some different peaks, like maybe this, both of these would be relative minima because they're relative, maximum, because they're relatively the highest point in their area, but only this one is the absolute max. So this would be an absolute max. This would still be a relative max. Okay, and so I don't think it's any shocker that the absolute minima will be the overall min. Of all relative min. But it's still in a specific interval for both of them. So I won't draw you a picture of the min. I think you can figure that out. Okay. So when we group these together, of course, we call them extrema. So absolute extrema, in other words, the absolute max or the min, will always be located at either a critical value Okay, and just to recap, remember a critical value will be either a turning point or what makes the denominator 0. We won't worry about when, not the denominator, but the first derivative equal to 0. We won't worry about when the first derivative is undefined because those won't be points at all, so they can't be extrema. Okay, but here's something new. It will also possibly occur at an endpoint. So the high or low has to either be at the start of the interval, at the end of the interval, or at a turning point in between. That's the only options. So this lesson is going to be somewhat short. In my face-to-face classes, we actually do it combined with the next section, just because it really is that short. But finding absolute extrema on an interval, we use this process. First, we make sure that f of x is continuous on the interval in question. Okay, we actually can't apply these principles if it's not continuous. So step number 2 is we're going to find all critical numbers or critical values in the interval. We're only going to focus on the ones that are points though, so to do that we're just going to set the first derivative equal to 0. We are not going to worry again about the critical numbers where the first derivative is not defined. For all critical values, and also for the endpoints, since the endpoints are options for absolute extrema as well, we're going to find the y. In other words, find the height of those points. So you're going to compute the y value, or f of x, right? F of x is the same as y. And then quite simply, the absolute max will be the largest of those, and the absolute min will be the smallest of those. So the absolute max is the biggest y value, and the absolute min is the smallest y value. So this method just gives you a smaller list to check. You don't have to try to figure out, did I come up with all the possibilities for the high and the low? The only possibilities for the absolute max or min could be a turning point or an endpoint. So let's do a few of those. So let's find the absolute extrema. For the following function. For f of x equals x squared minus 6x plus 7, but I want you to look on the interval from 0 to 10. So first we're going to find all critical values. Remember, we do that by setting the first derivative, which is 2x minus 6 equal to 0. So we get x equals 3. This is a critical number or critical value. And so it's a possibility for the overall max or min, but then so is the endpoint. So we're going to find f of 3. We're going to find f of the start of the interval, and we're going to find f of the end of the interval. Notice I'm plugging it into the original. So 3 squared minus 6 times 3 plus 7 is going to give us -2 for a y value. If we plug in 0, we're going to get 0 squared minus 6 times 0 plus 7, or 7 for a y value. And then when we plug in 10, we get 10 squared minus 6 times 10 plus 7. We get 47. So on this interval, we pick the largest one for the absolute max. Okay, so the absolute max is either the point 10 comma 47, or I'm pretty sure that MyMathLab just wants just the y value. And the absolute min in this interval would be the 3, -2 point, or again, if they just ask you for the y value, then it's just y equals -2. So pay attention to what MyMathLab asks for and just give only that. So pretty easy. We only had 3 options, right? We had 1 critical value, we had 2 endpoints, and so the max and the min and the interval between 0 and 10 had to be one of those 3 points. So a lot of times you're going to be given an interval and sometimes you won't. So when you're not given an interval, it's understood that it's over the whole graph. So 8x cubed minus 2x to the 4th, and let's say I was told to find the absolute extrema of this graph. So we're going to find the derivative, which is 24x squared minus 8x cubed, and you're going to set that equal to 0 to find the critical numbers. Notice we can factor out an 8x squared, so that's 3x minus x. Sorry, just 3 minus x. So we end up getting 0 and 3. Okay, notice these are the critical values or the critical numbers. And also note there were no endpoints given, which means there are no endpoints to check. So all you're going to do is check both critical values, and the highest one will be the max, and the lowest one could be the min, or maybe we don't have one, so we'll have to kind of think about that. Okay, so g of 0 is just going to be 0. G of 3 is going to be 8 times 3 cubed minus 2 times 3 to the 4th, or 54. So if we pay attention to what the graph of this would be, notice that we have a 4th power equation, right? So if you looked at the graph, you're going to see that it does not, it doesn't have a min. It goes down forever and ever if we look at end behavior. So there is no absolute min. Because we weren't given an interval, we have to look at, is there an overall min, and there isn't. But the absolute max, again, depending on how MyMathLab wants it, might be this point, or if all it wants is y, then just y equals 54. Okay, so let's look at another one. find the absolute extrema for f of x equals x plus 4 times x minus 2 squared for any x on the interval from 0 to infinity. Move that up, sorry about that. So the first thing is we're going to have to use product rule. So the derivative is going to be first times derivative of the second. Remember to use chain rule, right? So move the power to the front of that second term, reduce the power by 1, and then multiply by the derivative of the inside. Notice that's just 1 though. And then plus the second times the derivative of the first. So again, this is first. This whole thing is the derivative of the second plus the second times the derivative of the first. So you're going to end up getting 2 times x plus 4 and then times x minus 2 plus x minus 2 squared equals 0. So one way to do this would be to FOIL this and work this all out, or you can notice that they have something in common. In other words, this is optional, so I'm going to say you can use FOIL and simplify. Or if you're comfortable doing it, you can do what I'm about to do, which is factor out what they have in common. What they have in common is an x minus 2. Okay, and then what would be left if I factored that out is 2 times x plus 4 in the first group and an x minus 2 in the second group. And then we get x minus 2, that's equal to 0, times 2x plus 8 plus x minus 2. So we end up getting something that we can factor out here. This is 3x plus 6 equals 0. You could technically pull a 3 out, although it's not necessary really, okay? Because now notice I have something times something else equals 0, so now I can just set each thing equal to 0. So I end up getting 2 here, and I get negative 2 here. And again, if you're uncomfortable with the factoring that I just did, you can also FOIL and simplify and then factor that, and you will get these same critical values. Okay, so the first thing you want to do is make sure that these critical values are in the interval that we have. Okay, so notice this critical value should be ignored. So we're going to find it, but we're going to ignore it's not in the interval from 0 to infinity. Okay, so we don't really need to test that one. We actually just need to test f of 2. And then we also need any endpoints we have. Notice we just have 1. We have 0 as an endpoint. So I just need to pick these and plug these in. So if I plug in 2 to the original, I'll get 2 plus 4 parentheses times 0 minus 2 squared parentheses. So if you plug in 2, you get 0. And if you plug in 0, you get 0 plus 4. I did that wrong. Right up here, that should be 2 minus 2, right? Sorry about that. So that's how I got 0, right? So it should be plug in the x. I was kind of mixing the two, which we definitely don't want to do. So if you plug this in, you get negative 2 squared, which is 4, times another positive 4, which is 16. So notice we have a clear biggest and smallest. So the absolute max in the interval that I was given is going to be 0, 16. And the absolute min is going to be 2, 0. Okay. By the way, if you forget to ignore one, it might throw off what your maxes and mins are. So you do need to kind of pay attention to what interval you have. If you have a value, so notice -2 was not in the interval between 0 and infinity, so I needed to not even check it. It can't be a point if it's not even in the interval in question anyway. Okay, so that is probably one of the bigger mistakes that you need to be on the lookout for. Okay, be on the lookout for when you have a point that shouldn't even be included to begin with. So that's it for this lesson. It's a really, really short one. Again, that's why I said I combine it in my face-to-face classes. We will be using that in the next lesson. Okay, we'll be using the fact that we can find absolute maxes or mins.